Video for questions 42 through 44. Base your answers to the questions 42 through 44 on the cross sections below, which represent a particular location of the channel in the San Juan River in Utah. Changes in the river discharge Q in cubic meters per second and the sediment deposits before, during, and after the flood are shown. So it's showing a time period here from September 9th through December 9th. And it looks like it's going through maybe rainy season, or there's some sort of flood at this period. Number 42. During the time from September 9th to October 14th, the thickness of the sediment deposits at the bottom of the San Juan River's channel. So the first thing to note is that they're talking about from September 9th, this first image here, to October 14th, which is our second image here. So we're not even worrying about these other two. You throw them out, only look at the first three images here. Now it's asking you for the deposits at the bottom. And what it shows here is the little deposits down here, right? You see all these little sediments down at the bottom of the river. And it's really just asking, how thick are the sediments at the bottom of the river? Well, I think it's pretty simple to look at this question and just by eye be able to see. Right here you have 5 meters of sediments. Next, it goes up to maybe 6 or maybe 7, depending on what you think, what you look, but it's around there. And then it goes back down to it's maybe 5 in a place here or 4 over here, but the lowest point is about 2.5 or 2. So just by looking at this, you can see on September 9th to September 15th, it increases, and then from September 15th to October 14th, it decreases. The only one that works with is question number 4. There's really no canceling out or anything like that on this. You can really only cancel out on a lot of other questions, but not this one. It's really just an eye test. You have to look at it, use the chart on the side, and it will certainly give you a quick answer. You should be able to get that one right. Number 43. On October 14th, during the flood, the discharge of the San Juan River changed dramatically. The change in the river's discharge at this location was related to an increase in the rivers. So we're looking at October 14th, and if you see here, Q is 1,688 meters squared per second, right? And that is the river's discharge. And what that means, that's the amount of water that is being pushed down that river, the speed that is moving, or the amount of water that's moving through per second. So it's a lot of water. It's really, really fast. You can see the water is really high, and when we see higher water, we're typically talking about faster water. Now, what it's asking here is, what's really happening? Why is there so much more water here? Why is it moving like this? So the change in the discharge. Well, let's look at these answers, and we'll see if we can cancel anything out. If you look at number 4, you look at sediment deposits. Well, there are less sediment deposits here, but I don't know if that is really going to make it move faster, right? I mean, is the discharge of the river going to change due to the amount of sediment deposits? Not really. I know there's less there, and maybe you'd think that, okay, it's going to move faster because there's less deposits, but that's certainly not the correct answer. Number 3 says that the channel length. It doesn't really say anything about the channel length changing, and nor should it, because why would a channel get longer, right? Well, why would a river actually get longer or stretch out for some reason? And for the same reason, you can look at number 2 and say gradient. Okay, that's talking about how steep it is, right? So I mean, the whole river doesn't tilt or anything like that, so that can't be the right answer. The only correct answer that we have here that really makes any sense at all is the velocity, right? The increase in discharge is going to be due to how fast it's moving, right? So talking about meters per second, okay, that measures meters squared per second, okay, that measures the amount of flow. That means it's moving much, much faster. And velocity loosely means speed, so you can kind of connect the dots there And as long as you know what velocity means, you should be able to get this correct as well. Number 44. If the greatest velocity of the San Juan River on December 9th was 10 centimeters per second, what was the approximate diameter of the largest particles in the river could have carried? So we have to go to the reference table for this, but I just want to highlight a few things. Right? So we're talking about velocity again. So we're talking about the greatest velocity. We're talking about speed. And it's telling you it's 10 centimeters per second. Like I just told you, we measure things up here. It's kind of all on speed. So what is the approximate diameter of the largest particles that the river can hold? Okay, just so you know, diameter is the longest distance, typically measured in a sphere, from one side to another, going straight through the middle. Okay, it's the longest point. So we find our 10 centimeters per second on our reference table, and if you come over here, we find our stream velocity. It's in centimeters per second as well. We find that we're looking for 10. So we go to 10, and what we have to do with this chart is we follow our line up, and as we go up, we take it until we hit our solid black line, and then everything that is on this line, this dotted line right here, anything below it, it can move. So it can move clay, it can move silt, and it can move sand. But it didn't ask for which types of particles. It asked for the size of the particle. And right here on this dotted line, which splits sand and pebbles, it says 0.02. So we go back, see if that's one of our answers, and it is one of our answers. So the correct answer is number 4.